All right, welcome to the next video in 8.3. We're going to talk about rationalizing. Very similar to the division idea we were talking about earlier in the last section. If you recall, if we have square root of 7 over 36, we can simplify that a little bit by splitting it up, and thus we get no radical on the bottom. Now, it's common agreement amongst mathematicians that this is a pretty fraction, whereas something with a square root on the bottom is not a pretty fraction. This comes from the same idea as negative 1/2 being a pretty fraction, but 1 over negative 2 kind of not being a pretty fraction. And so really this next idea is, sorry, that's my husband, all about the idea of, a common syntax, okay? And yes, there are some applications later on. You would want matching denominators for a lot of things, but basically we don't want radicals in the bottom. So we're going to do something called rationalizing, which takes non-rational things like root 2 and makes them into rationals like a whole 2, okay? So the idea is we want to take any radical on the bottom and we want to make it a whole number on the bottom, okay? That's what the idea of rationalizing is. With some of them, it's very easy. With others, it's a little harder. So let's look at this first example here. This is a very unpretty fraction. It's not an inaccurate fraction, but it's not pretty, okay? In order to make this pretty, we want this to be a whole 7 on the bottom, okay? To do that, we're going to play off this idea that root 7 times another 1 would cancel the radical. Okay, so if I put another root 7 on here, what would I get? Pardon me, I think I wanted one more box here. We want it to be a whole 7. If I do that, if I multiply root 7 times itself, then what I get is root 7 squared. And they're going to cancel, and I get that whole 7. Okay, so it's kind of like negative times a negative becomes a positive. Root 7 times itself, the square root cancels, you get that whole 7. I don't want to change the fraction though, so I must do that to the top as well. Here, that doesn't really do anything all that impressive. You just get 3 root 7 on the top. And you might be saying, Miss Kay, that's more numbers. What the heck? Like, that's not prettier. It's nicer if we ever did have to combine this with another fraction. Okay, that's kind of the idea. Now, this is not the only way you can do this. If you have something like this, you can definitely simplify, as we've seen before. There are other ways to rationalize. Please keep that in mind as you move forward. Rationalizing is kind of a last resort, okay? So we want to see anything we could do to simplify out that radical on the bottom before we go to rationalizing. So sometimes you don't have to. This next one, it looks like we might. Let's go ahead and simplify this bottom, though. Let's see if simplifying helps. 12 is not a whole number, but I'm sorry, 12 is not a perfect square. It's definitely a whole number. 3 and 4, it breaks into 2 and 2. So it looks like I can pull a 2 out of here, and I would get 2 root 3 on the bottom. Simplify that a little bit. We get negative 3 over root 3. Darn it, still wasn't rationalized, but at least this time we don't have to multiply by root 12. This time we can just multiply by a root 3. On that last resort, oh, and look at that, it simplifies even farther. We can take the whole root out to begin with. Okay, so we get negative, or we take the whole denominator out. Alrighty, so there's kind of why you might want to use it as a last resort to see you get smaller numbers, they're easier to multiply. Sometimes something you didn't think would cancel begins up canceling, right? But again, you might want to do it at the end. Okay, another one. We've got a negative on the outside here. I'm just going to go ahead and throw that up top. I'm going to bank off the rule that if I have one radical, I can reduce it to 2. Careful, don't fall for the trap. We are dealing with a square root here, and so the bottom would not simplify to just 5. That's if it was a cube root. But I could simplify each one. Let's kind of bring the 18 over here. Oops, sorry, that kind of looks like my index is negative, which is not a thing. So I'm going to go ahead and make that a little prettier and pull that off to the side there. 9 and 2, 3 and 3. It looks like 3 root 2, so negative 3 root 2 over. Here's 125 here. Let's simplify that. We get 5 and 25, 5 and 5. I can take out a group of 5, but 1 5 would be left over. Okay, so unlike the last example, nothing simplifies yet. Looks like I will have to move to rationals. careful, I'm not going to multiply by another 5 root 5 here. That's too much. That's unnecessary. In this case, I just need to multiply by a root 5. And therefore, I would get the 5 that was already there and another whole 5, and I get 25 on the bottom. I've run out of room. Okay, we'll cycle it down. Over 25. Okay, what happens on the top now? I get these two combining. You get negative 3 root 2 times 5, which would be negative 3 root 10. And again, unfortunately, this time we see that 3 and 25 don't simplify any further, but at least now it's rational. It's a rational number on the bottom. It's a whole number on the bottom. All right. Let's keep going with this idea here. Same thing happens when you have variables in there as well. We can again split up those radicals, pardon me. We can split up those radicals. And then let's go ahead and simplify. 50 breaks into 5 and 10, 5 and 2. Got a group of 5 I could take out. 2 left over. I left myself a little space because M actually has 2 groups of 2 I could take out, and I've simplified the top. P, I have 5 P's. Looking for groups of 2 here, so I have P squared. Unfortunately, I have another root P, which means I am going to need to rationalize this. It didn't end up just simplifying out. If I had P to the 6th on the bottom, it would simplify out to P to the 3rd. I'd be done. Unfortunately, that's not the case here. So I need to multiply now by another P, and I will get 2 P's that were already there. Another P makes it, or times P, makes it P cubed on the bottom, which is nice and whole, whatever P ends up being. But I have to do that on the top as well. And so I have 5M squared root 2 root P, but I can combine those root P's, that root 2 and the root P, to root 2P. And I'm finished. All right, this last one here, just because it's getting a little messy, I'll go ahead and switch colors. We've got the cubed root of 27 or the cubed root of 16, kind of the same deal. 27 over the cubed root of 16. Now the cubed root of 27, 3 times 3 times 3 is actually 27, so that's a whole thing. But remember, we're dealing with cube here. 16's not going to be a whole cube. So we'll break that down, 4 and 4, 2, 2, and 2, and 2. So we got 2 cubed root of 2. Unfortunately, it is not rationalized as well. Sorry, just want to make that a little cleaner. What do I need to multiply to rationalize this, though? If I just multiply it by itself, what's going to happen? I'm going to get 2 times 2 2's under a cube. 2 squared under a cube is not going to cancel. That's not going to help me, right? I'm going to get that. And that doesn't simplify. The cubed root of 4 is not a whole number. And so that is not what I need to multiply by. Instead, what I'm going to do is multiply by 2 squared. In other words, the cubed root of 4. And that's going to give me another group of 2's. You see that? Another group of 3 2's. So I need to multiply by what is necessary to make that a whole number. When you're dealing with just squares for so long, it's common to think that it's just going to be the same thing. But that's not exactly true, right? Multiplying by 1 more works for a square. Multiplying by 2 more is going to work for a cube. If I had a 4th power, I need to multiply by 3 more. If I had an 8th power, I need to multiply by 7 more. You see where I'm going with this? In this case, now we get those canceling. Yes, that 2 was still there, and so we end up getting 4 on the bottom. Okay, but what I do to the bottom, I have to do to the top. We'll make it a 4 this time, because that's the same thing. We get 3 cubed root of 4, which doesn't really simplify. And neither does 3/4, so we are finished. All right. In the next video, we're going to talk a little bit more about rationalizing, kind of some bigger ones, and I will meet you there. I'll meet you there.